Hello and welcome to section 5.3 inverse functions. Now this section is quite of a review from pre-calc and algebra 2. So basically you should have all of this information, and it's just talking about the inverse function. If it is an inverse function, then if you plug the g of x function into the f of x function, you will get x, and likewise if you switch it around, you'll get x if they are inverse functions. And so we use f to the negative 1 as our inverse, and we are going to talk all kinds of things. So if g is the inverse of f, then f is the inverse of g, and so on and so forth. So make sure you get these down. The domain of the inverse is equal to the range of f, and the range of f inverse is equal to the domain. The domain and range switch places, so make sure you get that down. And the function it doesn't have to have an inverse, but if it does, the function is unique. And so make sure you have all of this down so that you know all about inverses, and this is what we've learned in the past. So then we're going to do verifying that these guys are inverses of each other, and so we are going to do f of g of x, and we are going to do g of f of x. And if these things equal x at the end, then they are inverses of each other. So the first one, I'm going to use this x, this thing right here, and plug it in for all the x's. So I get 2 times the cube root of x plus 1. Oops, and that's supposed to be a little smaller, cube root. X plus 1 all over 2 cubed. And so, cubed, it'll be cubed minus 1. So I get something that looks like that. And so if I cube this whole thing, that loses the cube root on top, and I end up with 8 on the bottom down there. Oh, the cube root is over the whole thing. It was over the whole thing. Sorry. That's what I thought. Okay. So cubing this thing will lose the cube root, so I'm really left with 2 times x plus 1 over 2 minus 1. And so these 2's will cancel each other out, so I'm really left with x plus 1 minus 1, which means that f of g of x will equal x. Now if I flip it around, will it work the same? So now I'm going to put in f of x wherever I see an x in my cube root. So in my cube root, I have, let's see, 2x cubed minus 1 plus 1. This is the x value right here. I'll just kind of underline it. That's the x value, and then plus 1, and then all of that's divided by 2. So that's all underneath my cube root. So combining like terms, I can get rid of those guys. And so now, and I can divide these guys out now. And so I'm really left with the cube root of x cubed, which means that g of f of x is x also. So yes, they are inverses of one another. If you don't get the same, you don't get x for each of them, then you did not. They are not inverses of each other. So then the next one, this is just talking about the existence of an inverse function. A function has an inverse function if and only if it is 1-to-1, and if a function is strictly monotonic over its entire domain, then it will be 1-to-1 and therefore have an inverse function. So make sure you get these definitions down. Pause it if you need to. So then they're asking for us to prove that it says which of these functions has an inverse. And so what I'm going to do is I can just look at this graph right here. Looking at the graph of this one is strictly monotonic, and so basically using my horizontal line test, I can say that this function does have an inverse. And I could find it if I needed to. This guy down here does not have an inverse because if I use the horizontal line test, which is like the vertical line test for functions, the vertical line test says that if it crosses more than once on a vertical line, then the equation that you're dealing with is not a function. This one, we have a horizontal line, and so if it crosses more than once, then it is not 1-to-1, therefore it is not it does not have an inverse, which this one does not. So the B does not have an inverse. And so here's some guidelines for dealing with inverses. There's a theorem in our book that we need to know. Solve for and basically to determine whether it has an inverse or not. And 5.7 basically says a function has an inverse if and only if it is 1-to-1. So this is the theorem that I was just talking about right here. So make sure you know that. That's that theorem. And then solve for x so that when we plug it in, so if we want to get the inverse, we'll switch x and y places and then solve for the new y. And that's how we're going to find the inverse, and that's this one here, and then define the domain and range, basically switching the domain and range places, and then you can verify by what we did in our example 1. So our final one here is we're going to find the inverse of this function, and we're going to find the inverse of this function by saying that if we have f of x equals the square root of 2x minus 3, then this is my y value, so I'm going to switch my x's and y's places. And now I solve for y again. So in order to get rid of the square root, I square both sides. So really I have x squared equals 2y minus 3. I'm going to add 3 across the equal sign, just solving algebraically. X squared plus 3 will equal 2y. And then if I divide by 2, I will have y equals x cubed plus 3 divided by 2, and that is the inverse function of the function up above. Now when you come to class, we are going to now jump into the inverse with derivatives and all of that stuff, and so please be prepared. Please watch these and make sure you guys are prepared for class.